Welcome back. This is Chemistry Central Science, section 19.6 on free energy and temperature. So we looked at Gibbs free energy yesterday, and Gibbs free energy says that essentially the amount of energy to whether something is going to be a spontaneous reaction is based upon two things. It's based upon the change in internal energy, which we call enthalpy, minus the Kelvin temperature times the change in randomness of the products called entropy. So all reactions tend towards maximum randomness. That normally happens spontaneously, or will dump a lot of energy and become very exothermic. That is enthalpy. And so the combination of these two will determine if something is going to happen by itself, like a tower of blocks falling down, or whether it's not, whether the opposite is true, and something will automatically arrange itself more in an organized manner. So this is talking about temperature. Since we've got temperature involved, you can make some guesses about temperature if you know the entropy and the enthalpy. You can know whether something is going to be spontaneous or not based upon the temperature. So for instance, ice, solid ice can turn into liquid water only at certain temperatures. So it's a spontaneous reaction for ice to melt when the temperature is above zero, but it's a non-spontaneous reaction for ice to melt when it's below zero. In fact, the opposite is true. If you have a Gibbs free energy that is positive, if your delta G is positive, then the reverse reaction is spontaneous. So if the reaction is water melting into ice, and you are below, or ice melting into water, and you are below zero, not only is it not spontaneous for ice to melt below zero, but the reverse reaction is spontaneous. Water will freeze into ice. Okay, so your three choices are: you have a zero temperature, or you have a higher than zero, or you have a less than zero. And so you can make some guesses if you know the other two terms. So let's look at the first part up here. So this is the formula for the Gibbs free energy, and so if you know that let's say enthalpy, if enthalpy is below zero, okay, and your negative T sub S is below zero, can you say if this is below zero and this is below zero, then delta G has to be below zero? So if you know a situation in which you know that the enthalpy is negative, and you also know that the entropy is positive, okay, so positive, more random. So look here, if this number is positive, and your temperature is positive, then the negative negating of two positives will make you negative. If both of these is negative, it's going to be a spontaneous reaction. All right, so do you see that this is not really hard? This is a simple math equation. It just looks a little scary. So let's look at another one. So let's write this again. Delta G equals delta H minus T delta S. Okay, Gibbs free energy. Okay, let's look at the other possibility. Let's say that this one is above zero, okay, and that negative T delta H is also above zero, which means that S is actually negative. if S is negative and T is positive, okay, then this is a negative number. And then when you negate a negative number, it's positive. So if both these is positive numbers, then your delta G has to be positive. And so that's non-spontaneous. Okay, non. So you're just making predictions. That's all you're doing. So the really only weird situation is if one of these is going to be positive, the other one negative, then delta G is going to be based upon how positive and how negative they are. Because when they combine, if the whole delta G is negative, then it'll be spontaneous. If the whole delta G is positive, then it'll be non-spontaneous. So in this manner, you've got to know what your T is, because T will determine which one is going to be bigger and whether or not G will be negative or positive. Okay, so here's where your three choices are: T equals 0, T is less than 0, or T is greater than 0. Okay? If T is equal to 0, right, then what's going to happen? So if temperature is exactly 0, then we've got a situation where your enthalpy is equal to your T delta S. Okay? So if that's true, when I subtract T delta S on the left and end up with 0 on the right, you'll end up with the free energy equaling 0. So what does that mean? If free energy is 0, if Gibbs free energy is exactly 0, then you are at an equilibrium. Your forward reaction is exactly the same as your backwards reaction. So let's imagine that with ice. So if temperature equals 0, ice is going to melt into water, and water is also going to freeze into ice at the same time. You've got a temperature point where both of these are in equilibrium together. Okay? That's pretty cool. What if temperature is less than 0? So if T is less than 0, then T delta S is less than 0, because T is negative, and that's a negative negative. This is crazy. You have to really think about this slowly, which means that your entropy minus T delta S is greater than 0, which means that it's non-spontaneous. So in terms of ice melting, it's non-spontaneous when the temperature is less than 0. So this would be non-spontaneous. So in the case of T being greater than 0, then your delta H is going to be less than T delta 0. So then when you subtract T delta S, you end up with delta G is less than 0, and this would be spontaneous. Okay. So, not the hardest thing I've ever seen, but it's confusing because you have three different options. This is like when you were in pre-algebra and you started the idea of minus a minus and plus a minus and minus a plus. Suddenly, everybody forgot that they could subtract. It's really just subtracting, but when you're multiplying by negatives, it still makes you have to stop and be careful and write it down slowly. And that's really all you're looking at, right? So I hope this helps you a little bit, and the practice is what you'll know if you understand by just doing some practice.